to the solution of a system of linear equations. Remember, we had decided to solve using a matrix. We'll say the matrix is called A, and sometimes we'll put m by n, m times m, or say m by n, and that means it has m rows and n columns. Columns are variables, rows are the equations. And then we use row reduction moves. We do put an augment, last column, onto that system of equations and onto the matrix, which is the constants. A couple of other terms. Two matrices are called row equivalent, and we write that with a little tilde, L squiggle B. L A is a equivalent to B using the tilde when you get from A to B by row reduction moves, or back, because row reduction moves could always be reversed. A pivot in a matrix B is a 1, number 1, in a row of B with two things true. First of all zeros come before it in its row, so all to the left of it are zeros, entries in the matrix, and all zeros above and below in its column. And then immediately we have this definition of row reduced echelon form of A. So it's a matrix B, it's equivalent to A, so you get to B by row reduction moves, where each row of B is either all zeros or has a pivot, 1 that we just described, and the pivots in earlier or higher rows up higher in the matrix are in earlier further left columns. You move all the 0 rows to the bottom. So here's an example of a matrix which is in row reduced echelon form. Notice that there's a couple of columns of zeros and a row of zeros all at the bottom, and then each row is either all zeros, like that last row, or it has a pivot. So the first 3 rows do have a pivot, and I put a box around so you could see where the pivot was. It's a 1, it has zeros all to the left of it, and it has zeros above and below it. The rest of the matrix you can fill in any way you want. They could be more columns of zeros, lots of numbers around, as long as it obeys those rules that each row has a pivot. Now, here's the key. If A is equivalent to B in reduced row echelon form, that's as far as we can go. That's as good as you can get using the matrix method, and at that point you have to interpret the answers. Oh, and we do say that a pivot column of A, the original matrix, is a column of A where that column in B has a pivot. So it's, for instance, if that was our B, the pivot columns of A would be the 1, 2, 3, the 3rd column, the 4 or 5, the 6th column, and the 8th column in that example. Right, that's a system is solved when its matrix A of coefficients is put into the reduced row echelon form B. Notice that you also do all those same row moves on the augmented column of the constants, but that column doesn't have to be in reduced row echelon form exactly. You could, but the only reason to do that would be to sort of simplify the final answer. Well, only time that would occur is if there is 0 answers anyway. So we'll get to that. I'll say how to interpret all these. So then once you get it in reduced row echelon form, and with the augment on it, you return it to equations, basically just by the same process as you made it in the first place. Each column corresponds to an original variable. Could be x, y, z, or it could be x1, x2, x3, x4, and so on. The augmented column is still constants. Each pivot in B is going to be a variable that gets determined. It'll be on the left of an equation. Each non-pivot column in B is going to be a free variable. It can be any real number. All right, here's best to see this by example. So here's an example of a row reduced echelon form matrix called B. Notice again, it's got could have entire rows of zeros, but it also does have a couple of rows that have a pivot in x2 and x4 there, or second column and the second and the fourth column, but in the first two rows have pivots. So as you go down, and we'll just go left to right, reading all the columns, every column that doesn't have a pivot is going to be a free variable. X1 is equal to free variable. And to write that, we just write x1 equals x1. We want to write an equation, and that just lets me remember that I can pick it any way I want to. It's free. When I get to the pivots, though, I get it more interesting. So x2, now I have to read the rest of that row. And so I get minus 2 times x5. I'm putting back the coefficients onto the variables that they're in the column for, and plus 5x7, because it's in the 7th column above x7, equals 3. That's the constant. When I get to x3, no pivot, so it's free. When I get to x4, it's a pivot, so turn it into an equation. x4 plus x5 plus 3x7. Those are the rest of the coefficients. Equals 1/4. That's the constant. And then when I see x5, it's also not a pivot. Notice it does have a 1, so just to put avoid possible error, pivots aren't ones necessarily. They're specifically ones that obey the rule that everything before them is a 0 and everything above and below them is a 0. So in this case, neither of those things are true for x5. It doesn't have zeros before it. x6 and x7 also not pivots, so they're all free. Next, we do need to keep going a little bit, solving the non-free equations, one for each pivot. But I will mention that since it has 5 free variables in this example, that means that our solution is infinite. You can pick any number you want for those free variables. What will happen is that then the last 2 variables, x2 and x4, will be determined. So solving each of those, the free ones are already solved, but I did need to solve x2 and x4 by just moving everything to the right-hand side. So, and then once it's like that, this is the final general solution. It's written as a new system of equations with the free variables just equal to themselves, and then the non-free variables equal to something, a formula using the free variables. If you want to see an example of a specific solution, all you have to do is pick any values for the free variables. So I said pick any next to x1, I just made it 0, x3, I made 1, x5, -2, x6, 3, x7, 0. The easiest thing to pick is 0 for all of them, but you can certainly pick some other numbers. It's totally free. And then you can figure out what x2 and x4 are. So you have to plug in the numbers that you picked into the formula for x2 and x3, which I move up. x2 was 3 plus 2x5 minus 5x7. So I plugged in that -2 and 0 that I chose, and I get 3 minus 4 is -1. And for x4, I plug in a -2 and 0 that I chose. I think I chose a -2 for x5, and just to make sure, yeah, 0 for x7. And so for x4, I get 1/4 plus 2. So 1/4 plus 8/4 is 9/4. And then there's my specific solution, a number for each of those variables. Now you can go back and check that that's a solution of the original system of equations. However, this time I didn't have one. I just showed you the row reduced echelon form.